Hello, everyone. It's very intimidating to be here, following up all of our amazing speakers. I think, all the accomplished engineers that talked at this conference, what I've done in my life does not even compare. But thankfully, I'm not here to talk to you about some hardcore tech that I invented, like SPy or something. I'm mostly here to entertain you, and hopefully you can go home with a thing or two learned along the way. So show of hands, who's used a function that looks like this before in their life? I'm sorry for you all. I think a lot of people have used this because it's from a very well-known ORM that is very widely used. And it doesn't even get better as you scroll through their docs. This is their description of these parameters. And I think that this was just a natural evolution of what started off as simple code that got the job done. But then people kept adding to it over time, and it got to this point. And we can't really judge grass for overgrowing, you know? We can't judge project requirements for evolving over time. It just happens. But at some point, you need to maintain them to keep them usable and in a good shape. And this is where garden tools and software design patterns help us. Like mowing the lawn with an electric lawnmower is a lot more efficient and easier than doing it with an old school scythe, even though scythes are making a comeback on YouTube nowadays. It's pretty nice to watch, I'm not gonna lie. So what are we doing today? We're gonna be exploring a problem and designing a solution that satisfies us. And we'll also be thinking about this design process together and judging each design we come up with. By the end of the talk, you'll go home with a couple more tools in your tool belt and some extra experience with designing good code, and also a reminder to check out YouTube videos with people mowing their lawns with scythes. I think it's time I introduced myself. I'm Rami, I'm a full stack engineer. I work a lot in AI, and I've been designing solutions like the one we're about to work on for a while and across domains. I'm also an open source maintainer of a few projects, notably Dataline, which is the latest. It's an AI-driven, privacy-first platform where you can query your data and explore it. And also PET, which is a simple command line snippet manager written in Go. This was a project that also I used for many years and very randomly became the maintainer of. And on Saturdays, you can spot me screaming while wielding a shinai. It's called Kendo. It's very fun. I can recommend it. And just yesterday, actually, some friends I train with got third place in the European Championships. So I'm extra happy today. First, let's start with a story. I'm going to tell you the story of Sam, who is a smart engineer and good designer. And Sam's company wanted him to design a document analysis web service client. It supported all kinds of documents as well as OCR. OCR is optical character recognition, for those of you who don't know, and it extracts text out of images, basically. And Sam was tasked with building a simple Python client for interacting with the service. The only requirement was to support text files, so none of the advanced service features were needed yet. So Sam goes ahead, starts with this task, and creates a simple function to call it. So we have a file, we have a couple of parameters, and a small doc string that explains what each parameter does. It's simple, right? Given the requirements, it gets the job done. I think this is a great design. And this is an example of its usage, where we're constructing the headers as a dictionary, and then based on each parameter, we're populating the dictionary and then creating a simple post request to the server. And now let me introduce a little activity that we're going to do together a few times in this talk. I call it a crowdsourced code review, although limited in dimensions. So we're going to judge the code together along these three dimensions: documentation, validation, and reusability. If you think the design does well in a certain dimension, I want you to raise your hand. If you think it's bad, just don't raise your hand. And then I'll look at you and, come up with a number that's not a binary number. And then I'll show you what I thought and why. And we can't really quantify code designs as they're, more craftsmanship and art, but For the sake of this presentation, we're going to accept the oversimplification. And I'm going to show you the code one more time, but in the next examples, try to think about this judgment as we are walking through the code. So for this one, what do you think, how do you think about its documentation? Raise of hands if it's good, don't raise your hand if it's bad. Do you want me to show you the example again? So this is the example. And these are the docs. And then we're also going to look at its reusability. So what do you think about the docs? Good. All right. And validation doesn't really apply here because we didn't do any validation. And what do you think about its reusability? All right, not so reusable. Here's what I thought. So kind of in line with what you guys thought, sorry. I think it's a pretty good design. It's simple. The documentation does its job because we just have 2 arguments. And we don't have validation. It's not very reusable because it's just a function. So we can't really copy paste the parameters as easily as an object, for example. So Sam delivers his work and everyone is happy. But a few weeks later, to no one's surprise, the project manager comes back and tells Sam, we need to add more to this. We want to support PDFs and images. We want timeouts for long analyses. And we want to find the bounding boxes of extracted words and more. So Sam decides to keep it simple and just extend this function first before we overcomplicate it and try to come up with a better design or whatever. Let's see what we're dealing with. And so he does that. I'm going to walk through the code without commenting on it much. So we have a bunch of parameters. There are a lot more parameters. And the docstring has also grown a lot because it needs to describe every one of them. And then we're constructing a headers dictionary based on each one of these parameters. Here you see we also have some validation. We want timeout to be an integer. We want it to be positive. And we want to check that the rotate angle is within something. So it's just to illustrate the point. And then we also have sub-options. So if OCR is enabled, we have some other options that only apply if it is enabled. And so this is, getting much bigger because it's just extending the function. The post is still the same. The usage is also just a function call. So still very simple to understand. Now, code review time. What do you think about the documentation? Raise your hands if you think it's good. Okay. Sketchy hand raises, but what about the validation? Okay, about 20%. And what do you think about the reusability? Okay, 0 hands. Very non-reusable. This is what I thought. I thought the documentation is not great because I'm also looking at it from a context of the code editor. So if I'm someone who's using this function and I want autocomplete, I'm going to get a massive docstring that I need to literally scroll through in the code snippet. So to me, that's not great docs, even though we are documenting every one of these arguments on its own. And the signature is pretty big, and the body is mixing validation with construction. So it's really, mixing responsibilities there. And it grows with the number of arguments, which is not great. Like this is maybe acceptable, but imagine you have a lot more options. And in reality, this is actually reflecting a real server from Apache called Apache Tika. And there are many more options. And I wrote this presentation when I was actually building a client for that web service. And so Sam doesn't like this at all. He thinks it breaks the golden principle, which is not leaving things worse than you found them. One second. So I think this principle is essential to living well, from writing good code to keeping your kitchen clean. Like it all goes back to the same thing, a mentality of caring about these things and maintaining them even if you don't feel like it. Like if you finished your dinner and you leave your plate in the sink, It's going to be 10 times harder to clean the next day. But if you just rinse it off or put it in the dishwasher, then you did some tiny maintenance, but you made your life a lot easier and you left the kitchen in an equally bad state, at least not worse. And so over time, I think this does matter and it does add up. So I think our code review also agreed with like my opinion, and we can improve upon this. And so Sam decides to iterate on this. So first of all, improvement ideas. We can separate the validation and construction. That's a simple win. And we can improve the reusability by having an object of options. Then we can pass the object around instead of having a bunch of arguments. And we can also get documentation per argument. Optimally, that would be what I want, because now I have to scroll through a big paragraph of docstring. I would like to have localized documentation. So I'm looking at parameter X. I want to see the documentation for parameter X. And these are the improvements we have in mind. And now keep in mind, we're talking about like all these improvements and how these docs are bad, but this doesn't even have a docstring. So just to give you some context, I had to double check, but even in their source code, there's not even a docstring describing what these parameters do. There's just a mention of these parameters. So I think we're still good, even though we're trying to improve further. And so Sam thinks of config classes. Why don't we use a class that handles these fields and maybe also handles the validation for us? So something like Pydantic would be a good fit here. We still have a big docstring, so that didn't improve much. Oh, I shouldn't comment on the code yet. And we have the fields, each one with its type, and then we have some validators which are defined using the Pydantic field validators. So the validation logic is now separate. We're still doing the construction as we used to before, and we still support the sub options. So now if the with OCR is set, only then do we check the sub options here. I think the sub options, oh, I shouldn't comment yet, again. And the getText function, we're just constructing the class and calling two headers and passing that into the request.post. So what do we think of this documentation-wise? Okay, not too bad. What about validation? I think there was a big improvement in validation. And reusability, also more reusable. Okay, here's what I thought. I think the validation was definitely much better because now it's separated and we can push it even further by using inbuilt Pydantic validations. In this case, we're still doing it manually just for illustration. And the reusability has improved because now config is an object and we can pass it around easily. And the docs are kind of the same still. It's one big doc string, which comes with the same disadvantages that we mentioned in the previous design. But yeah, in general, much better looking against our metrics. So can we do better here? It's good, but it's still lacking. I think it's sad to have a solution that doesn't self-document well, especially that given that this is a client for others to use. Like it needs to be self-descriptive, otherwise it's going to be very hard for other developers to use this code. Coincidentally, Sam is also a Go developer. And in Golang, we have a much more standard solution to this than we have in Python. And it's called functional options. Options is because we're passing parameters to a function, options. The functional part, well, you'll soon find out, but I'll give you a spoiler. It doesn't have anything to do with functional programming. So he wonders if he can translate that design from Go into Python and reap the same benefits that this design has in Go. And to show you what this design is, we're going to look at the end result first. And this is basically what functional options looks like. So we have a getText function that takes in the file, and then we have an options class And then within this options class, we have a few static methods. So with timeout, and that can take arguments. And then you can see the with OCR now. This one's a bit more interesting here because you can see the fact that sub-options are represented. And with rotation also can take arguments. So having functions for each one of the options is a lot more flexible because now we're going to get, a lot more control over each one of these options construction. And let me show you now how these methods actually work. It's going to be a bit weird, so bear with me. But yeah, you'll get a chance to review it in a second. So each one of these options returns a function. So you can see here we're returning a callable, which is apply, that itself takes in an options dict. So it's very weird once you first see it. Even Go developers find it very weird when they first encounter it. In the with timeout, you can see we have the validation in one section, and we also have the function getting returned and applied on the options dictionary here. And with OCR, same thing. We also have its own docstring, and it returns a function that applies these sub-options based on which ones were passed in. And this is how we loop over the options and apply them to the headers. So we start with an empty headers object, and then each option is called on top of the headers because each option is a function, hence the name functional options. And this is the usage again. So what do you think about this one, documentation-wise? Good, bad? All right. I think the documentation for this one is so good that I had to add a screenshot for the editor autocomplete, because as you're filling it in, you can get the documentation that's only pertaining to the argument you're trying to fill out now. So it really breaks down that massive docstring into sub-docstrings, and then they're localized to where they're needed. What do you think of the validation? All right, maybe a little step back. Reusability. Okay. I think it's also the same reusability-wise because we're kind of still passing around an object, although maybe a bit improved because now each option is defined separately. I think the validation is a bit less good because we don't have Pydantic anymore, so we don't have the power of the internal validators, and we're mixing it with the construction a bit again, but it's still not too bad. But there is one thing about it, though, that I think you all saw and probably felt that isn't described in our metrics. I think it's a bit too complicated and not Pythonic, right? Like we're returning a callable and we have to loop over the options and apply them. Like it's hard to use and also hard to define. So there has to be like something that we can do about it to improve it. And this also shows us the weakness of like using such metrics, because you can't define everything and quantify everything. Like there is a craft to it. And so this is what I thought and I just described. So from here, Sam was thinking about the solution to his problem, and then inspiration came to him from an unexpected place. So JavaScript, it's given us a lot, and I say this only half sarcastically maybe, but one thing it's especially recognized by is method chaining. You see it everywhere in JavaScript, and Sam, being a JavaScript nerd, his functional options implementation made him think of method chaining, like seeing these methods defined one after another, but separated with a comma instead of a dot. And this is kind of common in Python too, like it's not specific to JavaScript at all, it's just well known there. And I think some of you know where I'm going with this already. So builder and chain is a software pattern that allows us to build an object incrementally by chaining method calls together. And this is how you would apply it in this case. So now we're constructing one options object and then calling methods on that object. And so everything is now contained within options. We're still reaping the benefits of functional options because we still get the documentation advantages, and each one of the options is still a function, but it's now, a bit more standard to Python, let's say. And looking at the implementation, you can see that we have an internal state, which is options. So now the options class is handling this for us. We don't have to handle that outside. And then each one of these functions will just manipulate this internal state based on what arguments you give it. Same for the rotation. And then in the build, we're just returning the internal options just to give it like a nicer interface to the outside world. So Sam is pretty happy with his choice at this point. It's Pythonic, it's the best iteration so far, and I think we can skip the code review on this one because it's pretty similar to what we had in functional options, except it's simpler, which is an advantage. So I think it's still, not exactly the same thing as before. The metrics we had for the review didn't all improve and they didn't all decrease. So like this is the thing with designs, they're all very unique and special. But then why is it used in Golang since it's so complicated and twisted? Like, are all Gophers wrong to use this? Are they missing something simpler like method chaining and builder and chain pattern? Why is that not used there? And I think every time we ask ourselves a question like this, it's better to assume that we're the ones who are wrong, because the people who worked on Go are incredibly smart people, and we can only hope to compare in our life. So why is Go different? Is anyone familiar with Go here? All right, we have a few people. So the main difference here is error passing. I think at this point we have to say that Sam was about to get fired because he spent like a week iterating on this code in a perfectionist attempt, and even though he had something working from the first day. This is like a friendly reminder that time is always a constraint when we're designing things. We're never designing in a bubble. And yeah, going back to the subject at hand, error passing in Go. So it's a bit different than what you're used to in Python or Java, for example, or other languages where you simply throw an error. In Golang, you have to return the errors and then manually handle it. And this is like one of the decisions that were decided in a very dictatorship manner, but I think a lot of things require that kind of decision making. And it makes Go a bit special. It's not the only language to do this, but it's well known for it. And so doing method chaining here, where you're returning errors, is a bit weird, because now you need to handle the error somehow. And if you want to find a way around this, it's going to always come with downsides. Like, you're not going to be able to find a clean way around this without sacrificing something big in terms of readability, in terms of complexity, in terms of hiding away things from the user and adding magic to the thing you're designing. And so because of this, because the designers of Go didn't want to go down that route, they decided that functional options was a better design there, because it doesn't have to chain methods. And I'm linking an article at the end, by the way, to a more in-depth article about why you should avoid method chaining and Go specifically. So if you're interested in it, you can check that out. And this is basically, the TLDR of why method chaining is not as useful in Go. But in Python, we don't have this problem. In Python, we can simply raise errors, and that allows us to have much simpler designs. So this was also interesting to see where the same design pattern did not translate as well across languages, not because it wasn't buildable in that language, but because the language is different, and that brought in a tiny constraint that completely changed the face of our design. So, to sum things up, I'm going to quickly show you a side-by-side comparison of how our code evolved. And in a moment, we'll have some time for questions. So maybe start thinking about those and putting them in Slido. We started off with simple requirements, and we created an equally simple design. It was just a function call with a couple of parameters. And this was great. It wasn't complex, it was simple, and any more, and it would have been bad, actually. And then our requirements evolved, and we had to support many more options. So we tried extending the function first before trying out other designs, but that turned out to be quite bad. But in that exploration, we found what needed improvement, and that allowed us to propose a better design. Even though it didn't fix everything, it was still an improvement along some metrics that we had in mind. So it was kind of necessary to start with extension. And then we came across config classes, which improved things a little. The validation was cleaner, and the solution was more reusable, but the docs were still average. And then inspiration struck. We wanted to borrow a concept from Golang. And so functional options seemed to perform much better on all the metrics, but there was still something about them that didn't feel right in Python. And when we explored it better, it did seem to be more complicated than necessary. And thankfully, we knew JavaScript, which allowed us to find an even better design. And that was the builder and chain pattern, which is very well known in Python, but not standardized as functional options are in Go. I feel like Python is a bit more Wild West still in terms of standards. So this offered us the benefits of functional options, but it was more familiar in the context of Python. And it naturally led us to store the builder state inside the class, which led us to builder and chain. So at the end of the day, combining experience from these different domains gave us a bunch of different lenses through which to see our design and improve it. And so I think the more you explore and be curious, the more you'll be able to gain tools that will help you design better things. And I think we should also try to avoid scythes in favor of lawnmowers, even though it probably feels epic to wield a scythe sometimes. And these are some sources for the talk. Rob Pike was one of the people working on Unix and one of the creators of Go, and he was the first person to talk about this publicly. And then Dave Cheney made it a bit more common. John Calhoun talked about method chaining in Go, and he's also a very popular figure in Go education. And then I also wrote a blog post covering this when I tried it out at some point a few years ago, and that eventually became this talk. And here you can find a few links to my GitHub profile and all these projects, as well as some blogs and videos I've made. And I'll be around till the end of the day. Thankfully, I'm a bit shy to be approaching others, so here's an official invitation in case you have something to talk about. And thanks for your attention, and I hope you have a nice rest of your day. Take your time.
Okay, so we'll move ahead with the questions. So we have got two. You guys can add your questions on the Slido. So first question for you is there a reason to use camel case in static methods of option class?
No, I think it's not very Pythonic, but it is more fitting artistically, let's say, because it's coming from Go, where camel case is used there. So in my actual code, I wouldn't use camel case here. Good spot.
Okay, so next question. Is there a way to use functional optional options while also leveraging Pydantic powerful validators?
I mean, you could use Pydantic validation on its own, but yeah, I think builder and chain is already much better. So I wouldn't use functional options in Python in case this wasn't clear from the talk. Don't use this. Builder and chain is much simpler, much more Pythonic, but it was an interesting exploration as to why we shouldn't use this. I wouldn't also use Pydantic validators in a builder and chain function, because that would be a bit hard. Like you might incur a lot of extra costs constructing Pydantic models to perform the validation. You could hook into the internal Pydantic validators and use those straight away, but yeah, a bit sketchy.
Okay, so if anyone has questions from the crowd, they can come or they can add it on Slido because we are over here. Does anyone has any questions? Okay, so a round of applause for speakers.
Thank you.